Hello and welcome to another episode of TRX Bench. Well, today I have here an older VHF unit, Albrecht AE-550, and this radio came in with distorted transmit audio. So let's look into it and let's see what's happened, and let's see if we can fix it. Okay, and here's our radio up and running. It is receiving, but that was not the complaint. So let's check a little bit here our transmitter pass. Okay, so let's check here a little bit the setting. And yeah, light is on transmit and it is on low power. So we have an output power of 1.1 watt. Let me switch it to full power and let's see. Okay, so 27 watt. So radio is rated with 25 watt output power. So that seems to work fine. Our frequency is a little bit off, so 220 hertz. It seems to be off. I mean, that is not that bad for FM, but it's a little bit, so let's test that a little bit more precise. Okay, so therefore I've connected here my frequency counter. And the setting here on the radio is 145 to 90. So yeah, it is exactly the same what you can read down there as receiver frequency, right? And now I go to transmit, and let's see. And yeah, okay, so you see 222 hertz off. So yeah, that might be what we should tweak a little bit. I mean, it is in spec if the frequency error is not greater than 200 hertz, I believe, on FM. Especially on FM, it is totally different on SSB, but since this is an FM radio, we should do it a bit better, but that is not that bad. Okay, so let's go for our next test, and that is deviation. So first, oh! Wow! So have you seen this figure here? So that is 12 kilohertz, and that is quite a lot, so far more than it should have. So as amateur radio said, it should have approximately 5 kilohertz, so that would then be fine, but 12 kilohertz is much too high. So let me feed it here with a tone. First of all, I have to adjust here my 1 kilohertz generator, and now I feed it here in, and wow, so 10 kilohertz, and you see, now you can't see, sorry. Okay, but now you can see, I'm sorry for that. So 10 kilohertz here with a test tone, and just here blowing into the radio. You see 12 again with our tone generator. Sorry for the annoying tone. We are approximately, it depends a little bit how I have here my it depends a little bit how I have my speaker here on the microphone, but anyways, it is far too high, and you see that should be more or less an acceptable sign, but you see how distorted this signal is. Okay, and once again we see the distorted signal, and we see here our deviation. So now let's check here our distortion level, our transmit distortion level. Yeah, and you see, so that is really 30% THD on transmit, which is absolutely far too high, and that might be let me turn it down, and that might be the problem why our radio is distorted on transmit. So we need to crack open the radio and see what's going on with the deviation settings. So maybe deviation is set far too high, and that is what we check. And for those of you who wondered how I have injected here my signal, so that is very easy. So this is a normal speaker, and I put it here onto the microphone like so, and then I turn on here my sine generator, right, and the 1 kilohertz tone goes directly here into the microphone. So that is an easy way to get 1 kilohertz directly here into our microphone without opening the microphone and get it down to the wiring to connect my little sine generator directly to the radio. So that is a way how you can easily and fast check the deviation with simply an audio generator, and that's for all of you who are interested how to do it. Anyways, next step is let us crack open here the radio, and let's see what we can find. Okay, so here have we our radio cracked open, and well, so that is quite simple. We have down here our deviation pot, which we wanna try out if we can bring it back to, let me say, 5 kilohertz to be able to get a much better distortion on transmit. Well, since the microphone which is connected here to the radio is a power mic, I do not really trust this CB master, whatever. So I would like to try an original Albrecht microphone, just for test purposes and for alignment, to be sure that everything is fine. So therefore let me simply put here this to the radio, and let's see. Okay, so we can obviously transmit. That looks fine, and I get output power, no problem whatsoever. But what is this? We do not get any deviation with the original microphone. Well, and this looks funny too. So if you look, I don't know if you can see it, but it looks like that the inner contacts has been removed. at a point, I don't know, but here our pin 6 right in the middle, so that should be our DC voltage for our electret microphone. So we need DC voltage to operate it, and I mean, as I said, it is switching, so no problem whatsoever, but I'm a little bit confused because we should get modulation here with the original one. So let us check if we have here voltage present at pin, what is it? Pin 6, I believe. Yeah, pin 6. Alright, so we put it around this way that we get access here to our microphone connector, right? And right in the middle, so that means down there, we should have our DC voltage. Yeah, let's have a look into our schematic. Okay, so we see here the microphone jack, and yeah, so here we have our microphone amplifier, and we have here, so this is here our deviation pot, so that is what we need to adjust to go back to, yeah, let me say 5 kilohertz. And here our pin 6, so right in the middle is the one which gets supplied with 13 volt. So when we go over here and follow here our trace, so we get up, let me see, okay, so yeah, if we follow here along, so you see over our switch, where's the switch, here's the switch, we get our plus B, which we can see here, and yeah, that is over our on switch, our power supply for, or our DC voltage for our microphone, and that should be present at pin 6. So let's check what we have down there. Okay, so this way we should see what we need to see, and here we are right in the middle. That is what I already expected, so there is definitely nothing, it is dead, so no 13.8 volt, 13 volt, whatever. So our supply voltage should be at least at pin 6, I believe. Yeah, pin 6, but it is not. And so let's see what we have else. Back here to our schematic, and what we see here, pin 6, we have here a little coil L105, which is here the HF suppressor, and very often when somebody is working on equipment like this, a short on our power rail very often destroys these little coils. So let's see what we can find. And don't know if you can see it, so that is our L105, and yeah, so there it is printed here on the board, and have a look. So something is wrong here, so there is definitely a burning mark, and yeah, so I believe that coil is open, but let's better check it before we can finally judge. Okay, alright, so this is one end, so that is obviously our connection to pin 6, and then on the other side of the coil, yeah, so that is exactly what I thought. So I believe that whoever did here the modification to get this CB master to the VHF radio, whoever did this, he seems to have trouble with this DC supply, and I believe that therefore he removed the contacts out of the connector. But before he did it, I could bet he blows this coil so that we do not have any power for an original microphone. Well, just for testing we can bridge it, because as I said, so this is only a filter, but for testing purposes we can bridge it so that we get here our 13 volt to pin 6, and then we can try once again our original microphone, and if we get then modulation with this microphone here. Yeah, and as I said, we do it quick and dirty here for testing, and yeah, let me zoom out that you can see the meter, and let me go down to pin 6, and yeah, so now we have back here our 13 volt. That means let's try if now our original microphone plays. Okay, so now let's see if our original microphone is working. Yeah, okay, so power, we get power out, and now let's see what's on here with modulation. Yeah, and you can see it is 14 kilohertz. So first of all, the original microphone is now working, and that is due to the fact that now a DC supply is back for the capsule here inside, right? And 14, 15 kilohertz, so that is definitely much too high. So let's try to bring it now back to normal. Okay, so with the original microphone, without any pre-amplification, let me try what we can do here with my audio generator, and you already see that the signal is already much better. And now let me try to turn it back. I have to go down here to our pot, and let's see what we can do here to get it managed somehow. 1 second here, we will get it managed, and alright, so that is already much better, the result we have here. And you see that is now a much better sign. So now we really get here a nice sign. So you can see it. Let's check the distortion, and 3%. So that is definitely better. And again, here we can increase a little bit. So let's see that we get here a nice outcome. And yeah, so that is fine. So we do not overdrive it here. We need, of course, a little bit more here audio. And now you see we can reduce it a little bit. And okay, so now we are fine for sure. That is fine. And we have a nice sign. Everything is good. Okay, so I have tested here the amp microphone, and I can say so that is producing distortion as well. So both the wrong aligned deviation setting and this amplification microphone together produces a high distortion. Now our setting for deviation is back as normal, but still with this microphone the distortion level is bad. So really I have to talk to the owner. So it is definitely no good idea to use this microphone. So I believe that something is wrong here with this microphone as well. I do not want to check it because normally that doesn't make any sense. So that is a cheap, crappy microphone. So no need to fix it. And well, I have to talk to the owner. So maybe we have to replace the little coil in order to be able to use a normal microphone for really good audio. And to be honest, you really do not need amplification microphone, a power microphone for FM VHF radio. So that is from my point of view that does not make really sense. Of course you need a good microphone with a good high quality capsule inside, and with the right deviation setting you can be sure that a VHF radio sounds simply great without any question. Okay, so now what I want to do is let me align our oscillator a bit. So we have seen that the radio frequency is off, and we have our crystal down here, and there we can tweak a little bit the crystal frequency, and let's see that we can do it a bit better, that it is not off over 200 Hertz. Okay, so let's bring the radio into transmit, and here we are. So we are 250 Hertz off. So let's see if we can do it a bit better. I know this little capacitors here are very sensitive, and that is what you can see already. But yeah, so that is fine. So that is an FM radio, and as I said, tolerance is here not that critical. It is different on SSB. So on SSB we do not want to have a frequency error greater than 30 Hertz. Here it can easily be 100 Hertz, but if we can do it any better, like right now, so you see our frequency setting is 145 290, and now the radio is 6 Hertz or 5 Hertz, whatever, so it is jumping a little bit. That is quite normal. That is now a nice setting, and I will leave it alone, so that is just fine. Alright, so we are at the end of our video, and even here with our power mic we have limited our deviation so it does not move beyond 5 kilohertz, 5.5 kilohertz. So that is just fine, even it is still distorting the audio, and therefore, as I said, throw it away, it is crap. Anyways, that is it. So that was nothing special, but I hope you enjoyed it a little bit, and that you have seen that we also have to take care on our transmit audio as well as on our receive audio, and that is what I wanted to show you. Additional to that, it is not good to really overdrive your deviation, because you will splatter, however you pronounce it, splatter I believe, into your neighborhood channels, and you know that does not make any sense, because even that you are disturbing your neighborhood channels if there is a QSO running, additional to that, power from your transmitter is going into your neighbor channels as well, and that does not make any sense. So please do not turn on your deviation pot. So if it is 5 kilohertz, it is really just fine. So there is no added value if you open it completely, that you have, I don't know, 14-15 kilohertz. That does not make any sense. Don't do it. Alright, so that's it for today. Thanks for watching. Hope you enjoyed it a little bit, and bye. Catch you next time.